Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. The topic is something called heat capacity, and I thought I was going to get this out to you much earlier this evening, but ran into some snags in the sense that what I wanted to do, and you'll see this in a second, was compare how air temperatures and water temperatures evolved during the course of a year. Well, the climatology for water temperatures, or at least the only thing I could find, was split up into thirds of a month. So the 1st to the 10th, the 11th to the 20th, the 21st to the 30th or 31st, and the normals for air temperatures are daily. And so what I had to do was find a city where I could download the daily highs and then compute the averages for those thirds of a month. And it had to be in a format that Microsoft Excel could accept, and the first several attempts that I made, it was not compatible with Excel. So finally I found a file that was, and was able to compute those averages, and now finally I have a finished product. So sometimes things, I had a trig teacher in high school that said, why make something easy when you can make it difficult? That's the way I felt tonight. All right, so let me put myself down here in the corner and let's talk about the definition of heat capacity. The heat capacity of an object is the heat required to raise the temperature of that object by 1 degree Celsius or 1 degree Kelvin if you prefer, and the larger the object, the greater the heat capacity. So obviously the ocean is going to have a much greater heat capacity than a puddle of water. Okay, the heat capacity for air is 1.005 joules per gram degrees Celsius. Now don't worry about the units here. The only thing worth remembering is the numbers. So just keep 1.005 in the back of your mind for a second. And the heat capacity for water is more than 4 times that, 4.184 joules per gram times degrees C. So obviously it takes a lot more heat to raise the temperature of water by the same amount of temperature, if you will, than it does for air. So let's actually put this into practice here and take a look at some actual data. So what you're looking at here through the year is a plot of the water temperature. The dotted line there in blue is the water temperature, and the dotted line in tan, if you will, is the air temperature. Okay, so all through the year. And by the way, I'm comparing this at Myrtle Beach, the water temperature at Myrtle Beach, to the air temperature at Florence. I wanted to get far enough inland so there was no effect of the ocean on the land. Okay, so Florence is about 80 miles inland, so obviously it's not going to be affected by the ocean because it doesn't have any proximity to it. So there you can see those plots. And what I want to point out here is that the air temperature bottoms out, the normal air temperature at Florence bottoms out in maybe the 5th to the 10th of January, somewhere in that general neck of the woods. But the water temperature doesn't bottom out until the early part of February. So there's a lag there. And the same thing happens, except in the other direction, in the summertime, is that the air temperature peaks, the normal air temperature peaks in Florence in the middle of July, but the water temperature does not peak until the early part of August, okay? And then another thing worth noting here is look at the rate right after that blue, where you see that blue line there. Look at the rate at which the air temperature is beginning to descend, and the rate at which the water temperature is beginning to descend is not as rapid, okay? Now, the personal story that I wanted to tell you about this relating to my dad is that back when I was a kid, eons ago, we didn't go back to school until the Friday after Labor Day, okay? So what he would do is he knew that the hotel rates were going to crash as soon as you got past Labor Day, okay? But the water temperatures were still very, very warm, and the crowds weren't nearly as big, okay? So what he would do is we would take our vacation at the South Jersey shore, Wildwood Crest to be specific, and we would go from the Thursday before Labor Day to the Thursday after Labor Day, and that meant that half of those days were going to be at the lower rate, okay? But the water was still warm, it wasn't as crowded, and so it was actually quite pleasant. And this is the reason why a lot of people, maybe retirees as well as parents with really, really young children, like to go after Labor Day because it's cheaper and the water's still warm and the crowds aren't as bad. Okay, so this heat capacity really comes into play and helps to create an environment for those two groups that is very, very favorable. Now, the same thing applies on shorter time scales as well. Okay. The reason a sea breeze develops is because the air over the land, once the sun comes up, heats up much more rapidly than over the ocean. And that's because the ocean has a higher heat capacity, so it requires more heat to raise the temperature of the ocean by the same number of degrees. And so a temperature gradient starts to develop between the land and the water, and once that gradient gets to about maybe 10 degrees Fahrenheit, then a sea breeze circulation is born. Now at night, the land is going to cool more rapidly than the ocean will, and so if the land becomes significantly cooler than the ocean, then a land breeze develops. So instead of having the wind coming from the ocean toward the land, now it's blowing from the land out toward the ocean, if indeed the land temperature gets significantly cooler than the ocean water temperature. So these same principles apply on long time scales and also short time scales. And again, it works in people's favor at least some of the time. Now, the downside of this is in the spring, when the air temperatures are starting to really come up and the water temperatures are slower to respond because, again, it takes more heat to raise those water temperatures. And this can really be felt along the East Coast when we get these what we call backdoor cold fronts. Anytime the wind blows from the northeast along the eastern seaboard during the months of maybe March, April, and May, the water temperatures are very chilly off the middle Atlantic coast. And so the wind blows over top of that cool water, and then that cools the air above it, and all of a sudden the areas that are bordering on the ocean are getting very, very chilly. In Chicago, the same thing happens with Lake Michigan, where in the spring months it can be 70 degrees at O'Hare, okay, which is about 10 miles inland from Lake Michigan, but right along the lakefront, if the wind's blowing from the northeast, it can be in the 40s, okay? Even in April and May, that can happen. So again, that's the downside of it in the spring, but the upside is in the late summer and early fall when the water temperatures remain warm for a longer period of time than the actual air temperatures do. Okay, hope that makes a little bit of sense. That is bonus weather video number 2 for this week. Number 3 will be coming up on Friday, and the next daily update, of course, coming up tomorrow. So you all have a good one, folks, and we'll talk to you soon. See you later.